Hello students, now we are going to start another unit, unit 2 on signal conditioning and data acquisition. So here we are going to see these topics, basics of signal conditioning, filtering, amplification and linearization, basics of signal conditioning, analog to digital conversion and digital to analog conversion, basics of signal conditioning, sample and hold circuits. We have data acquisition systems and its components, data loggers, LabVIEW role in signal conditioning or data acquisition, interfacing sensors with control systems, PID controllers. So these are the topics we are going to see in this unit. So coming to the basic measurement system, these are the basic components. You have measurand, and you have sensor, transducer, signal conditioner, recorder, display processor, or this is the output device. So when you have this simple basic system, you will have a sensor stage. So that is the first stage. From here the signal is sent to transducer stage, where the transducer converts to right form of the signal that is suitable for next stage. So that is signal conditioning stage. So here there are so many processes involved in signal conditioning that few important concepts we are going to see in this unit. Then we have output stage. This is control stage. So this acts like the control signal, like it acts like feedback system, and the feedback signal is sent back to sensor stage. So the control signal is sent back to sensor stage. So this is a simple block diagram of measurement system, and you can see the different components of measurement system. So signal conditioning, we have different processes, very few and important processes only we are going to see in this unit. It is all about a signal that is in analog form. Normally, the signal output from sensor will be in analog form. That is to be converted into a digital form. That is, and from digital form to analog form. Suppose if you want to send signal to actuator, again you have to convert from digital form to analog form. Then the actuator can recognize that analog signal. So in between we have so many processes in between input and output. We have so many signal conditioning processes. So here there are many possible functions in signal conditioning stage. Some of the common functions are amplification, attenuation, filtering, differentiation, integration, linearization, combining a measured signal with a reference signal, converting a resistance to a voltage signal, converting current signal to a voltage signal, converting a voltage signal to a current signal, converting frequency signal to a voltage signal. So these are the few very important processes. Apart from this, we have other processes also, but we are going to see very few important concepts like amplification, filtering, A to D conversion, D to A conversion, and sample and hold circuits. So these basic signal conditioning processes we are going to discuss in this unit. Signal conditioning circuits are used to process the output signal from sensors of a measurement system to be suitable for next stage of operation using amplification, attenuation, nonlinearities, linearization, or multiplication by another function. So this is the signal conditioning circuit, simple definition. So signal conditioning, the output signal from the sensor of a measurement system has to be processed in some way to make it suitable for the next stage of the operation. So here the from Sensor, the output from sensor is normally a analog signal that is to be modified in order to accept by the processor or a control system. So control systems are most probably are digital systems. They need only digital input. So we have to convert a sensor output, analog output into digital signal. So these signal may be, for example, too small or have to be amplified, contain in interference which has to be removed. So interference, some sort of disturbance, be non-linear and require linearization, be analog and have to be made digital, be digital and have to be made analog, be a resistance change and have to be made into current, be a voltage change and have to be made into a suitable size current change, etc. So these are all the examples of signal processing. All these changes can be referred to as a signal conditioning. For example, the output from the thermocouple is a small voltage, a few millivolts. So a signal conditioning module might then be used to convert this into a suitable size current signal, provide noise rejection, linearization, and cold junction compensation. So cold junction compensation is just for the cold junction not being at 0 degree Celsius. So this is cold junction compensation. So this is simple signal conditioning, and processes are like this. The following are some of the processes that can occur in conditioning a signal. First one is protection. So mainly it prevents the damage. To prevent damage to the next element, microprocessor as a result of high current or voltage. So thus there can be series current limiting resistors or fuses to break if the current is too high, polarity protection and voltage limitation. So these are all the protection to the next stages, like microprocessor or some other digital device should not get damaged. Getting the signal into the right type of signal, this can mean making the signal into a DC voltage or current. Thus, for example, the resistance change of a strain gauge has to be converted into voltage change. So resistance change to be converted into voltage change. This can be done by the use of a Wheatstone bridge and using a out of balance voltage. It can mean making the signal digital or analog. So this is the right type of signal. And we have getting the level of the signal right. So level should be right. The signal from the thermocouple might be just millivolts. If the signal is to be fed into an analog to digital converter for inputting to a microprocessor, then it needs to be made much larger volts rather than millivolts. So here we are going to use op amps. Operational amplifiers are widely used for amplification, so eliminating or reducing noise. For example, filters might be used to eliminate main noise from the signal. Signal manipulation. Example, making it a linear function of some variable. The signals from some sensors, example a flow meter, are non-linear. Thus, a signal conditioner might be used to so that the signal fed on to the next element is linear. So linearization or manipulation. So this can be done using using signal conditioning unit that may consist of operational amplifiers and the types of op amps. The necessity of signal conditioning may be due to following reasons. Signal may be too noisy due to electromagnetic interferences. Signal may be too small, usually in terms of millivolts range. Signal may be non-linear and required to be converted into linear form. Signal may be analog one and required to be converted into digital form. Signal may be digital one and required to be converted into analog form. It may be required to improve the quality of digital signals. So these are the few reasons why you require signal conditioning units. So mechanical amplification and electrical signal conditioning. So just to introduce amplification, just mechanical amplification is a classic example where mechanical amplification by the elements such as linkages, gearing or cans is quite limited. These are cams is quite limited because of the following disadvantages. When amplification is required, frictional forces are also amplified, resulting in considerable undesirable signal loadings. So these effects results in poor response. So here almost all linkages, gearings, cams, cam follower mechanisms, all these are having contact. So there will be frictional forces will be associated with these linkages. And here advantages of electrical signal conditioning is such conditioning may be typically include converting resistance changes to voltage changes, subtracting offset voltages, increasing signal voltages, removing unwanted frequency components, ease of power amplification. Additional power may be fed to the system to provide greater output power than input power of the amplifier. So these are the main advantages of electrical signal conditioning. So functions of signal conditioning equipment. Signal conditioning equipment may be required to perform following functions: amplification, enhancement of the signal level, modification or modulation, changing the form of signal, smoothened, linearized, filtered, or converted into different form, impedance matching, matches the input and output impedances to maintain the level of the signal, data processing. It carries out mathematical operations before recording or indication of data. Data transmission transmits data from one location to other. The whole task of the signal conditioning requires the following: uh, inequity, proper selection of components, then faithful reproduction of signals. So ingenuity. So these are all the requirements for signal conditioning, and these are we can see in next slide. The excitation sources may be a DC voltage source or AC voltage source. DC excitation source example is a strain gauge. The strain gauge resistance transducer constitutes one or more arm of the Wheatstone's bridge. So Wheatstone bridge will be containing three uh, known resistors and one unknown resistor. So upon balancing this, we will come to know the unknown resistance. So the bridge can be balanced by using a potentiometer and can also be calibrated to indicate the unbalanced condition. The DC amplifier should have the following characteristics. Its input stage may be balanced differential inputs giving a high CMRR, common mode rejection ratios. It is the ratio of desired signal to undesired signal. So it should have extremely good thermal and long-term stability, easy to calibrate at low frequency, able to recover from an overload condition unlike an AC system. So these are the DC excitation source. And then the main disadvantages of a DC amplifier is problem of drift. So drift is the main problem. It is the static characteristic, and hence low frequency spurious signals are available as data at the output. And to avoid this low drift of a DC amplifier, special low drift DC amplifiers are used. The DC amplifiers is followed by low pass filter, and the filters we are going to see in coming sessions, which is used to eliminate high frequency components or noise from the data signals. So this is the DC signal conditioning system. So the measurand, and you have sensor unit, transducer, and you have bridge circuit, and DC excitation source is given to bridge, and calibration and zeroing network. DC amplifier is connected with the power supply, and you have low pass filter, and output is taken from this conditioning system, signal conditioning system. So this is simple block diagram of DC signal conditioning system. So in order to overcome the problem of drift, so drift is the main disadvantage in this DC system. In the DC systems, AC systems are used. So the transducers used are of the variable resistance or variable inductance type. They are employed between carrier frequencies of 50 kilohertz to 200 kilohertz. The carrier frequencies are much higher at 5 to 10 times the signal frequencies. The output of a transducer is applied to the bridge circuit, whose output is an amplitude modulated carrier signal, and this waveform is amplified by an AC amplifier. This amplified modulated output is then applied to a phase sensitive demodulator, the current signal. This produces a DC output that indicates the direction of the parameter change in the bridge output. So this is the AC excitation. In a carrier system amplifier, frequency drift and presence of spurious signals are not much of a problem. However, it is more difficult to obtain a stable carrier oscillator than a DC stabilized source. So this is uh, another disadvantage here with the AC system. And active filters can be used to reject this frequency and prevent overloading of the AC amplifier. The function of the phase sensitive detector is to filter out the carrier frequency components of the data signal. To summarize, DC systems are generally used for common resistance transducers such as potentiometers and resistance strain gauges. The AC systems are used for variable reactance transducers and for systems where signals have to be transmitted via long cables to connect the transducers in to signal conditioning system. After physical quantities like temperature, pressure, strain, acceleration, etc., have been transduced into their analogous electrical form and amplified to sufficient current and voltage levels. So, for example, 1 to 10 volts, they are further processed and the amplified signal applied directly to the indicating recording or control systems. So, this is the similar system like we see we saw for DC signal conditioning system. So here we have measurand, transducer, bridge, and carrier oscillator is used here. Calibration and zeroing network, AC amplifier, and power supply is given. It is a AC system, and phase sensitive detector, and we have low pass filter like DC signal conditioning system, and we have output. So this is AC and DC signal conditioning systems, and there ends this basics of signal conditioning. If you want to know more about signal conditioning, I request you all to read the book known as Linear Integrated Circuits by Rai Chaudhary. It is a very good book. Apart from that, we have few books. So this gives you a preliminary uh, content, right? Preliminary content. These books. So if you want to know more, better book is Rai Chaudhary. We stop here, and then we will see. We will meet in next session. Thank you, students.